Good morning, everyone. Am I audible?
Good morning. Yes, ma'am.
And what about the slide? Is it visible?
Yes, ma'am.
Okay, so I think by now we have done 8 experiments. We've discussed them. And today is the turn of the 9th experiment. Is it? Tell me the objective of the last experiment that we have discussed. What was the objective of the last experiment?
The redwood viscometer.
Determination of viscosity with the help of a Redwood's viscometer for a given
Yes, ma'am.
lubricating oil. Yes, so that was the experiment that we had discussed on the previous turn. Again, today we have an experiment that is related to lubricating oils. Today we will be discussing the determination of another characteristic of oils, which is going to be the aniline point. Is slide number 2 visible to everyone?
Yes, ma'am.
Yes.
So the experiment that we have to discuss today, the objective for that experiment is that we wish to find out the aniline point of the given sample of fuel, or you can say oil. Now, before I ask you the definition of aniline point, first of all, tell me chemically what this compound aniline is. What is chemically aniline? Formula for it. I want the formula.
C6H5NH2.
C6H5NH2 means that is an aromatic benzene ring to which is attached an aniline group. Yes. So the compound is aromatic in nature. Now tell me the definition, if anyone of you know the definition. I think you have studied about this characteristic in your theory classes. Anyone knows what is the definition of aniline point? If not the definition, like what is the physical significance of this characteristic for any fuel or oil? This we will discuss in the theory. Is slide number 3 visible to everyone?
Yes, ma'am.
Yes. So the definition, definitely you have studied about this in your theory class, which is given at the bottom of the slide. It is nothing but the lowest temperature at which any oil is completely miscible with an equal volume of aniline. So what you will do, in fact, if you understand the definition, if you know the definition, you can picturize the experiment as well in your minds. What needs to be done simply? You need to take an equal volume of aniline and the given lubricating oil, and you will simply monitor at which temperature the two will become completely miscible with each other. So the lowest temperature at which they will become miscible, they will form an homogeneous mixture. A homogeneous mixture, that temperature will be recorded as the aniline point for that given lubricating oil. So the experiment is quite simple. Nothing much needs to be discussed in this. But before we go into the details of the experiment, let us talk about a little about the physical significance of aniline point. See, it has something to do with the quality of the oil as pertaining to the ignition quality. You wish to find out what is the ignition quality of any oil. And if any oil has a high aniline point, that will indicate higher ignition quality. So if a question is asked to you, whether a higher or a lower aniline point is desirable for any oil, the answer is going to be what? High or low?
Low.
How come low? You want the ignition quality to be good or bad?
High.
High. So as I have highlighted on the slide right now, a high aniline point will indicate higher ignition quality. The ignition quality is going to be better, good. Now, what is the role of aniline in this? Let us come to that. See, the ignition quality depends on the proportion of paraffin hydrocarbons in the fuel. Now, what is the meaning of the term paraffin? This is another name for what? What class of compounds? Paraffins? Paraffins is another name for what class of compounds?
Unsaturated.
Alkanes, yes. If you remember petroleum also, what are the main constituents which are responsible for the ignition quality of petroleum? What are the contents of petroleum? They are methane, butane, isobutane. These are the contents, aren't they? So they are all alkanes. So if the paraffin hydrocarbons, they are present in greater amount, then the ignition quality of oil will be better. On the other hand, not only paraffin hydrocarbons can be present in any oil, but the aromatic hydrocarbons can also be present. Now, that means in any fuel or oil, there is a mixture of paraffins and aromatic hydrocarbons. And the aromatic hydrocarbons, they have a tendency to mix readily with aniline. Why can they mix readily with aniline? Because they are of the same nature. Means aromatic hydrocarbons can mix readily with an aromatic compound, which is aniline. Aniline has been chosen as the standard. Now this becomes easy if the aromatic hydrocarbons are present in higher content, then even at room temperature, they can be miscible with each other. But if paraffins are present, if alkanes are present in higher proportion, what will happen? That paraffins will mix with aniline at higher temperatures. That is why a high aniline point, what will that mean? That will mean higher paraffin content. And higher paraffin content, what will that mean? That will mean higher ignition quality. So for better ignition quality, the aniline point should be high, which will indicate higher paraffin content. Is that clear? And there is one more aspect related to this. Say if the aniline point is low. If the aniline point is low, that will mean it will contain higher aromatic hydrocarbons. And if aromatic hydrocarbons are present, then there is one more problem. They have a tendency to dissolve natural rubber and the synthetic rubbers also. So what will happen? If aromatic hydrocarbons will be present in higher quantity, then not only will they lower the ignition quality of the oil, but at the same time, they will damage the oil sealing or packing, which are usually made of rubber and used in the machines. So for packing, if the sealing which is used that is made up of rubber, then the aromatic hydrocarbons will dissolve that rubber and even the quality of oil will be deteriorated. The seal will be definitely destroyed by these aromatic hydrocarbons and even the quality of oil will be spoiled. So that is why we want the aniline point to be higher, because a lower aniline point will mean that the ignition quality will be lower, number one, and number two, it can dissolve the sealing and the packing of the oil as well as the machine parts. if any of the parts rubber is involved in connecting them or any other thing, then those parts made of rubber, they will be dissolved by the oil, and this can deteriorate the machine as well as the oil. So is it clear why a higher ignition aniline point is desired? Is desirable for any oil? Yes.
Yes, ma'am.
So this was about what aniline point is and what is the physical significance of aniline point. Now coming to the description of the apparatus, it's quite simple. You can see a water bath in which this U-shaped tube is immersed. In this U-shaped tube, we will take equal volumes of aniline and the lubricating oil. In one of the arms of this U-tube will be immersed a thermometer, which will record the temperature definitely, and in the other arm will be immersed an electrical stirrer. That has not been shown here in the diagram. I will be uploading the video. In the video you can see in the other arm will be immersed an electrical stirrer. So this you can see, this has been mounted on a machine. This is a stirring hot plate, a hot plate with stirrer. A hot plate, as you can see, it has two knobs. One knob is being used for controlling the temperature. With the help of this knob, you can control the temperature of this water bath, and with the help of the another knob, you can control the speed of the stirrer. So there are two knobs here in the hot plate. One is for regulating the temperature of the water bath, and the other knob is for controlling the speed of the stirrer. And figure A and figure B, they are of the same apparatus. It is just the view which is different. In figure A, you can see the front view of the aniline point apparatus, whereas in figure B, it is the side view of the aniline point apparatus. So is the figure clear? There is nothing much to be discussed in the figure.
Yes.
Yes. So let us come to the procedure now. As I have told you, what we will be doing, equal volume of aniline and oil, they will be heated to effect complete dissolution, and then they will be cooled under control conditions. Now, this is what you have to observe, and this is something which is different from the definition. The definition says the lowest temperature at which the two, oil and aniline, they will be mixed with each other. They will be completely miscible with each other. But the temperature that you will record or you will observe, that is going to be the temperature in which, when you will cool down the homogeneous solution and the entire mixture becomes cloudy, that you will report as the aniline point. And why is that done? Means we are not recording the temperature at which the two will become miscible. In fact, we will doing just the opposite. We will record the temperature at which both of the two liquids, they will start separating. And won't the two temperatures be same? It is exactly the same as if water is turning into ice and ice is turning into water. What is the temperature for both of these changes? Water turning into ice and ice turning into water. What is the temperature for both these changes?
0 degree.
It is the same. Equilibrium is there. Similar is going to be the condition here. We will not note down the temperature at which the two liquids, they will become miscible. In fact, we will record the temperature at which the two will become immiscible, and the temperature is going to be the same. And why is that done so? it has something to do with the observation. The observation for the latter is easier as compared to note down the temperature at which the tube will become miscible. Is that clear?
Yes, ma'am.
So the observation is easier. And how will that be observed? Once you will see that a homogeneous mixture has been obtained by heating. After that, what you will do, you will remove the U-tube from the water bath. You will allow it to cool. And when you will see a hazy, a cloudy solution throughout the U-tube, that temperature you will record as the aniline point of the given lubricating oil. Now, how will the experiment be performed? The apparatus will be thoroughly cleaned and dried before starting the experiment, the U-tube we're talking about. Then 10 ml of pure and dry aniline. Now this you're not supposed to do, you will be provided dry aniline. Otherwise, this aniline is dried over pure potassium hydroxide pellets. Do you understand the meaning of the term pellets?
And small crystals.
Not exactly crystals. If you flattened any sphere, the shape it will acquire, it is going to be the shape of a pellet, or it can be something similar to the tablets you have seen.
Okay, ma'am.
So potassium hydroxide is commercially available in solid form. You must have used it always in the form of a solution, but that is prepared from that solid potassium hydroxide. So potassium hydroxide pellets are available. What you will simply do, you will pour aniline over potassium hydroxide pellets. Whatever water will be present in aniline, that will be absorbed by the pellets, and then simply you can filter it so that the pellets are removed and you will get dry aniline. And if any other impurities are present, then it is also distilled and the other impurities can be removed, especially distilled aniline that is taken. These are extra precautions, but this you don't have to perform in the laboratory. And pure and dry aniline, 10 ml of it is taken in a heat resistant Pyrex or Corning test tube. Test tube is mentioned here, but in the experiment that you have to perform in the laboratory, that is going to be a U-tube shaped tube, in fact, U-shaped tube. Pyrex or Corning test tube, specifically this has been mentioned, such that the expansion of the tube is minimum with temperature, so a good quality tube is used. And to that, 10 ml of pure and dry aniline and equal volume of the lubricating oil will be added. Then I told you there are two arms in the U-tube. In one of the arms, with the help of a cork, an electrically operated stirrer is inserted, and in the other arm, a thermometer will be inserted, such that the bulb of a thermometer is about 5 millimeters above the bottom of the test tube. I just want to tell you that the bulb should not be touching the walls of the tube in which you will be taking 10 ml of aniline and 10 ml of oil, because you have to record the temperature of this mixture and not the glass or the tube in which they are being poured. Then you can see 2 points on slide number 6. Is it visible to everyone? Slide number 6.
Yes, ma'am, it's visible.
The first part I have shown in red because this is not your case. In this point, they have discussed the situation in which aniline and oil will be miscible at room temperature. So if they will be miscible at room temperature itself, means that without heating, they will be miscible. Then what you will have to do, you will have to use a non-aqueous cooling bath. A cooling bath has to be used such that you will lower the temperature below 25, and then you will note down that cloudy point. But this you don't have to do because the oil that will be supplied to you, that is gonna be not miscible with aniline at room temperature. That means heating will be required. So you will be following the alternative pathway if the two of them, the two liquids, they are not miscible at the room temperature, then slowly and carefully the jacket is heated. The U tube we're talking about, holding the tube either directly or by immersing in a hot bath. So hot bath will be used. You will be immersing the U tube containing the oil and aniline in a hot bath. Stirring is continued while slowly raising the temperature until the aniline oil mixture is completely miscible. When they are not miscible, you will be able to see two layers, and when that oil, when that layer separation will be not visible, then you will assume that the two of them have become completely miscible. Once they have become completely miscible, now it is a turn of cooling. Is slide number 7 visible to everyone?
Yes, ma'am.
So once they have become completely miscible, the jacket holding the tube is withdrawn from the hot bath, and then the stirring is continued, and the temperature is allowed to fall at a rate of 1 degree per minute. This is not in your control. You will be simply cooling the contents of the U tube in air. And then what is the temperature that you have to record? The temperature at which the entire aniline oil mixture becomes cloudy or hazy throughout. It has to become cloudy and hazy throughout. That temperature you will record, and at that point the outline of the thermometer bulb should be visible. So at that temperature you will record the aniline point of the oil sample. So this was all about the experiment. It is quite direct and simple. As regards the observation, not much you have to mention. Is slide number 8 visible to everyone?
Yes, ma'am.
So simply you will mention the least count of the thermometer that will be used, and then the lowest temperature at which the oil was completely miscible with an equal volume of aniline, say it is 62, and finally you will report the result that the aniline point of the given sample of fluid was 62. So this was all about the experiment. Are there any questions? Now only one experiment is left, that is the determination of steam emulsification number. Even that is quite simple and direct. I could have taken it today itself, but still we have time. We have one more week to go, so I thought I will take it on the next turn. I want you to complete this experiment in your practical file and upload it till Sunday. After the class, I will be sharing the link with you, and you have to draw the figures in your file, and you have to report the procedure as well. Is that clear? I will be uploading the video as well as the contents of today's class as soon as possible. So, are there any questions, or should I stop?
No, ma'am, no question.